Right. So let's configure this. All right. So we've got we're going to do compound interest. We're going to try to understand what compound interest means, and then we'll try to understand some of the formulae that you need to use to calculate compound interest. Sebastian leaves £3,000 in the bank for 2 years, and it earns compound interest of 2% per year. What does compound interest mean? It means that after the first year, you've gained 2% interest on whatever amount it was, and then on the second year you gain another 2% on the new amount, right? So first of all, if we imagine, what is 2% of 3,000? Let's do a symbol. It's a bit of a squash now, isn't it? Got to tidy that up. There we go. 2% of 3,000. I think you're able to do this bit okay, aren't you? So what would you say 2% of 3,000 is? Let's see if you can do that. Okay, so we're not using a calculator for this question. So 1% of 3,000 would be 30. So 2% is going to be 60. So I say 2% is going to be £60. So therefore, after one year, so 1 year has passed, and the new amount that they've got is £3,060. Okay. Now, after the second year, it's going to be not 2% of 3,000, but another 2% of 3,060, because the new balance at the start of the second year, or at the end of the first year, was 3,060. So it's going to be 2% of 3,060. So I'll do that now. Well, 1% of 3,060. So let's just do that over here. 1% of 3,000. I always forget the symbol. And 60 is going to be, well, before it was 30, so it's going to be 30. Why do I always forget the pound symbol? £30.60. So 2% is going to equal £60. Well, it's going to be 61. Every time I forget the pound symbol. £61.20. So you're going to, so it's 60. So before it was £60, but the second year he gained an interest of £61.20, and that makes sense because he's got more money, and so the interest is going to give him more actual money in reality. So we're going to now add £61.20 to £30.60. So after the second year, bit of mental arithmetic here. The way I do this in my head is I add it. In fact, what I might do on pen and paper is I might just go, well, let's add 60 first, and we'll add the £1.20 afterwards. So I go 120, then add £1.20, and so 120. So that's the new balance. Therefore that's the total amount of interest he's gained after 2 years. Okay, does that make sense more or less, do you think? So now that was with no calculator. Now, if I did have a calculator, I might have taken some shortcuts, because when I worked out a 2% increase, I worked out what 2% was, and then I added it to the original. But I can just go 102% is going to be equal to a 2% increase. So I could say if I want to just go straight to 360, I can just go 3,000. So in other words, let me just delete that bit and start again. So what's a 2% increase on 3,000? Well, you just take the 3,000 and you multiply it by 1.02. Instead of multiplying it by 0.2, you multiply 1.02, and you're going to get the same answer. You're going to get straight to that, 3060, right? And then what after the So after the second year, so gone. Yeah, sorry about the confusion. So basically, if I did like £3.20, sometimes I do that. So maybe I'll make a point of not doing that. Looks like 3 take away 20. So, but be aware that other people might do that. So anyway, so now we're going to do, if I do 1.02 times 3, so to get to the final answer, I would do 1.002 times 3060. Well, and then I would get the final answer, right? So that's what I would do if I could use a calculator. Now I could even do something else. I could skip a few of these calculator stages, because eventually what I did is I did 1.02 times the answer to a previous calculation. So instead of actually doing that previous calculation, I could just do 1.02 of all of that. So I could do that multiplied by 1.02, and that would give me my final answer. Yeah? I'd recommend rewatching this part of the video. This is when it gets a bit tricky, especially because we're kind of introducing a new idea. So this part of the video is where it gets difficult. The first part is kind of like, okay, I get that, and now I'm trying to show shortcuts. All right, and I'm trying to derive a formula. So what I'm doing here is I'm getting the original amount, which I don't know. There is going to be a formula. I'm just going to call this O for original amount, and we're going to call. So we're going to say, so this is O is equal to the original amount, and then 2. We're going to call the interest, and then as 2%, and then 2 years as well. We're going to call that time. Okay, but the formulae can look different for different situations. So what have I got? I've got the original amount multiplied by the interest, and then multiplied by the interest again. Well, when we do this, we don't actually need the the brackets. Oops. So it's just going to be the original amount multiplied by the interest multiplied by the interest, which is the same as the original amount multiplied by the interest squared. Right? Okay. Right. Now, why is it squared? Because I multiplied it by itself twice. Why did I multiply it by it twice? Because it was 2 years. So this power is the t. So we end up with the formula, the final amount, come on, is equal to the original amount multiplied by the interest to the power of the amount of times that the interest happened. If the interest happened every month, then you have to count how many months it was, right? So that's that last bit was the difficult bit. The first bit was the easy bit, if you didn't completely understand that difficult bit, don't worry, because we're gonna revisit it. But I just wanted to see if you got the general gist, and then we'll revisit it, and it'll be more familiar. All right, and you can also rewatch the video, of course.